So integrals requiring long division and completing the square. Integrals with long division and completing the square. So problem number 1, the integral from 1 to e of x squared plus 1 over x dx. You know, you don't have to use long division here. You could certainly break this up into x squared over x plus 1 over x dx from 1 to e, and that's the integral of x plus 1 over x dx from 1 to e. But when we get further into this worksheet, we're going to have to do long division. So I think I just want to take a quick look at how I would do this with long division. X goes into x squared plus, don't forget the 0 placeholder, plus 1. What do I multiply to make this? I multiply by x, and I subtract, and I get 1. So plus 1 over x. Aha! So when I do this long division, this integral turns into that integral. So the antiderivative here is x squared over 2 plus ln of x, and I want to evaluate that from 1 to e. So I have e squared over 2 plus ln of e minus 1 squared over 2 minus ln of 1. Okay, the ln of e is 1, so we've got e squared over 2 minus 1 minus 1/2, and the ln of 1 is 0. So I get e squared over 2 minus 3/2, or e squared minus 3 over 2. E squared minus 3 over 2 is not one of my choices, so I must have made a mistake somewhere. All right, let's go back and take a quick look and see where I made my mistake. E squared, x squared over 2, ln of x, I like that. E squared over 2 is nice. Ln of e is 1. I plug in a 1, I get 1/2. Then I plug in a 1, and I get 0. Ln of 1 is 0. Okay, so, oh, I see, this is a plus. So this is a minus. So I actually don't have minus 3. I have 2/2 minus 1/2 is 1/2. So I get e squared minus 1, and that's choice A. Choice A. Oh, God. Let's check again. Positive 1 minus 1/2 is 1/2, not negative 1, but positive 1. And again, that's going to be choice not A, but B. There we go. Okay. Blind calculus teacher does it again. 2. Integral 1 over x squared minus 2x plus 2 dx. Well, I can rewrite this denominator as x squared minus 2x plus 1 dx. Why do I want to split this 2 up into 1 and 1? Well, because when I think about completing a square here, I would really like this to be a perfect square. Right now I can't factor this as a perfect square. In order to factor this as a perfect square, we need b minus 2 squared. So b is negative 2. Negative 2 over 2 is negative 1. Negative 1 squared is 1. So this number here needs to be 1 in order for this to be a perfect square trinomial. Well, I happen to have 2 here. So I took 1 from that 2 to complete this square, which now factors as x minus 1 squared, and then I have this extra 1 down here in the denominator. Hey, this looks a lot like an inverse tan, doesn't it? And so we get tangent inverse x minus 1 plus c as our integral, and that is choice E. Choice E for number 2. Okay, number 3. Number 3 is 1 to 2 x squared minus x minus 5 over x plus 2. So I see the degree here is greater than or equal to the degree here, and that makes me think I should be doing some long division. X plus 2 into x squared minus x minus 5. You know, before the long division, it might be worth thinking about, can I factor this? Because maybe I can factor and cancel. But this numerator isn't going to factor in a way that allows me to cancel out that x plus 2. So I'm just going to keep going on with my long division. And I'm going to say, okay, x times what makes x squared? That's x squared plus 2x, and subtract, minus 3x minus 5. What do I have to multiply this by to turn it into this? I want a negative 3. Negative 3x minus 6, and then I subtract, and I get 1. So this is plus 1 over x plus 2. So this integral that I couldn't integrate here now becomes the integral from 1 to 2 dx of this, which is pretty straightforward. X squared over 2 minus 3x plus ln x plus 2 evaluated from 1 to 2. Okay, so let's see. I get 2 squared over 2 minus 3 times 2 plus ln of 4 minus 1 squared over 2 minus 3 plus ln of 3. This is going to be 4 over 2, or 2. 2 minus 6 is negative 4, plus ln of 4 minus, so 1/2 minus 6/2 is negative 5/2, plus 5/2, minus ln of 3. Minus 8/2 plus 5/2 is minus 3/2, plus ln of 4 minus ln of 3. All right, do I see that? I see a minus 3/2, but look, 2 logs joined with subtraction. I could condense those. Minus 3/2 plus ln 4/3, and lo and behold, that turns out to be, for number 3, choice A. This was not present. This was present here. I had to combine these like terms and condense my ln in order to get answer A for number 3. Let's take a look at number 4. Number 4 looks like another completing the square problem. We've got 1 over x squared plus 4x plus 5 dx. No, this is not going to factor as x plus 1, x plus 5, because that would make x squared plus 6x here. So instead, I'm going to think about x squared plus 4x and then plus 5 over here and think, well, what do I need to add to complete this square? Well, we said before, b over 2 squared. Our b value is 4. 4 divided by 2 is 2. 2 squared is 4. So I need to plug in 4 here. Well, I happen to have 5 over here. So let's take 4 of these 5 and put them here, which will leave me 1 over here. So now we're saying this integral can be rewritten as x squared plus 4x plus 4 plus 1 dx, or the integral of 1 over x plus 2 squared plus 1. And again, we've got an inverse or arctan. We say tangent inverse x plus 2, actually arctan x plus 2 plus c. And that turns out to be choice A for number 4. Choice A for number 4. Let's take a look at 5. 5 is the integral 6x squared minus 4x minus 25 over x minus 2. And don't forget the dx. Well, you know, I think about factoring that denominator as a 3x and a 2x and a 5 and a 5. and I'm going to get 15x, and I'm going to get 10x, which could give me a 5x or a 25x, but not a negative 4x. So, and if I change this to 6 and 1, 30 and 5, yeah, no, not so much. So this isn't going to factor. I won't be able to cancel. The degree of the top is larger than the degree of the bottom. So this is a prime candidate for long division. And so we've got 6x squared minus 4x minus 25. What do I multiply this by to turn it into that? How about a 6x? We get 6x squared minus 12x. Don't forget you're subtracting a negative. So we get 8x minus 25. And what do I multiply this by to turn it into that? I would use an 8. That's going to give me 8x minus 16. And so when I subtract, I'm going to get 9, negative 9. So then this is plus negative 9 over x minus 2. So this integral that I couldn't integrate can now be rewritten as the integral of 6x plus 8 minus 9 over x minus 2 dx. And you may find it helpful to separate this 6x plus 8 dx minus 9 integral 1 over x minus 2 dx to better see that you'll have 3x squared plus 8x minus 9 ln x minus 2 plus c. Okay, so this is multiple choice, and it looks like choice A. Number 5 is choice A. Okay, let's take a look at 6. 6 is the integral of 12x squared over 2x plus 1. Again, the degree of the top is bigger than the degree of the bottom, and so I think, hey, I should use some long division here. 2x plus 1 into 12x squared plus 0x plus 0. What do I have to multiply this by to turn into that? I like a 6x here, so that's going to give me 12x squared plus 6x, and then I'm going to subtract. I have negative 6x. What do I multiply this by to turn into this? How about a negative 3? That gives me negative 6x minus 3, and subtract for 3. So plus 3 over 2x plus 1. So I can rewrite this integral as the integral of 6x minus 3 plus 3 over 2x plus 1 dx. This is pretty straightforward. This is going to be 3x squared. This is going to be minus 3x. And this one I feel a little more tentative about, a little more unsure. I suspect it's going to be an ln. I'm going to do a u sub here with u equal to 2x plus 1. And I take the derivative of both sides. And I get 2. So du equals 2 dx, or dx equals du over 2. So I can replace this with du over 2, and I can replace this with u. And so I'm going to have 3 over u du over 2. I'll pull these constants out. 3x squared minus 3x plus 3 halves integral 1 over u du. And then I can see that I get 3x squared minus 3x plus 3 halves ln of u, and our u is 2x plus 1. Don't forget the plus c. This was problem number 6, and it looks like this is choice C for problem number 6. Choice C for problem number 6. Okay, 7. We've only got 3 more here. 7. We have the integral of 4 over x squared plus 4x plus 8 dx. I like pulling out that constant, 1 over x squared plus 4x plus 8 dx. So, you know, the degree here is not the same as or bigger than, so I know it's not that. And gosh, this worksheet says using completing the square, so I quickly identify this as a completing the square opportunity. Remember, b over 2 squared is what we need to add to complete this square. Our b value is 4. 4 divided by 2 is 2. 2 squared is 4. So I really want x squared plus 4x plus 4. Well, I have this 8 here, so I'm going to take 4 from that 8, and that will leave me 4 left over. And so I can rewrite this integral then as 4, 1 over. This is a perfect square trinomial. It factors as x plus 2 squared. And now I have this plus 4 dx. Aha! I remember doing these. I had to divide here by 4 and multiply by 1/4 simultaneously. So that then leaves me with 4 over 4 integral 1 over x plus 2 squared over 4 plus 1 dx. So I can think of this then as x plus 2 over 2 being squared plus 1. So my u is 1/2 x plus 2. Therefore my du is 1/2 dx, or 2 du equals dx. So I can replace this with u, and I can replace this with 2 du. My new integral then would be 2 integral 1 over u squared plus 1 du, or 2 arctan of u, and our u was x plus 2 over 2. X plus 2 over 2 plus c. Okay, tangent inverse. I got 2 tangent inverse x squared. There we go. That is choice D. Choice D for number 7. How about 8? 8. The integral from -1 to 1, 3x squared plus 2x plus 1 over x plus 2 dx. And this degree is bigger than that degree. This is not going to factor to allow me to cancel. So I'm just going to do long division, x plus 2, 3x squared plus 2x plus 1. What do I multiply this by to turn into that? 3x. 3x squared plus 6x, and subtract. We get -4x plus 1. That's a -4. -4x minus 8, and subtract. And that's going to be a 9 plus 9 over x plus 2. So then this integral becomes the integral of 3x minus 4 plus 9 over x plus 2 dx from -1 to 1. That'll be 3x squared over 2 minus 4x plus 9 ln x plus 2 from -1 to 1. So if I plug in a 1 here, I get 3/2 minus 4 plus 9 ln 3 minus, and I plug in a -1 and square it. -1 times -1 is +1 times 3/2 is 3/2. I plug in a -1 here, and I get +4. I plug in a -1 here, and I get the ln of 1, which is 0. Okay, so if I distribute this negative, I end up with -8 plus 9 ln of 3, which is in fact choice C. They didn't use the power rule here. Great. So there's problem number 8 all set, and our last problem on this worksheet is another long division. 2x plus 3 into 4x to the third. Don't forget your 0 placeholders. What do I multiply this by to turn into this? A 2x squared gives me 4x to the third plus 6x squared, and subtract negative 6x squared. What do I multiply this by to turn it into this? The negative 3x. So we get negative 6x squared minus 9x. And we subtract 9x. What do I multiply this to turn into this? That would be 4.5 or 9/2. So we get 9x minus 27/2 and subtract, and that's 27/2. Okay, so plus 27/2, 2x plus 3. So then this integral, 2x squared minus 3x plus 9/2 plus 27/4x plus 6 dx. This is going to be 2x to the third over 3 minus 3x squared over 2 plus 9/2 x. And then here, I like a u sub, 4x plus 6 du equals 4 dx. Dx equals du over 4. And so this becomes 27 integral of 1 over u du over 4. So I get 27/4 ln of u, which is 4x plus 6. Don't forget the plus c. All right, so yes, 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 wah, wah. There's my 27/4, but with the 2. I've got to go back and look at that long division again. Yeah, sorry. It's worth it. So when I do this long division, I ended up with 2x squared minus 3x plus 9/2 minus 27/2. So then I write the integral of 2x squared minus 3x plus 9/2 minus 27/2 over 2x plus 3. Okay, so this part, no worries, 2x to the third over 3, 3x squared over 2 plus 9/2 x. Now this, let's take a look at this. 27/2 over 2x plus 3 dx. So if I take out this constant, and I make my u 2x plus 3, then my du is 2 dx, or my dx is du over 2. So then I'm going to be able to rewrite this as negative 27/2, integral 1 over u, du over 2. This 2 comes out with this 2, and I get negative 27/4 ln not of 4x plus 6, but of 2x plus 3. And that turns out to be choice C. Choice C. Okay, so be careful with your algebra, as always. Hope this worksheet helps. You build your understanding, and I'll see you in the next one.